In a velocity versus time graph, the area of the graph represents the displacement of the object. The displacement can be found using the basic area formulas for rectangles and triangles. If the area is above the horizontal axis or the x-axis, it is a positive displacement, meaning it is moving to the right. If the area is below the horizontal axis or x-axis, it is a negative displacement, meaning it is moving to the left. To give you a bit of a review, the area of a rectangle, we take the length times the width. And to get the area of a triangle, we take 1/2 the base times the height. To find the displacement for each section, we're going to figure out those areas, and then we'll get the total displacement by adding those areas together. We want to be sure to give a positive or negative sign, whether it is above or below the horizontal axis. So in this first graph here, first thing we should do is we should label our horizontal axis. So there's the 0. You notice that everything is above that horizontal axis, and so therefore we will have only positive displacements. Okay, now to find this here, what we're going to do is we are going to find first the area of section A. We find the area between the line of the graph and the horizontal axis. This makes a triangle, so therefore the area is 1/2 the base times the height. The base is the bottom part, and we see that it goes from 0 to 4, so that base is 4. And the height part is from the bottom, which is 0, to the top, which is 20. So the height is 20. That gives us an area of positive 40 meters. It is positive because it is above that horizontal axis, which I will use a highlighter here maybe to make it a bit more exaggerated. Now the description of the motion is that because it is above that horizontal axis, it is moving to the right. And during this situation, during this section, we are moving positive 40 meters. So we're moving 40 meters to the right. For the second section, part B, again, we want to find the area between the line and our horizontal axis. So we're going to find this area here. This is a rectangle, so the area is length times width. The length in this case is from 4 to 7. That's a length of 3. And the width is from 0 up until 20. So that is 20. It is above the horizontal axis, above that line I just drew. And so therefore it's positive. And 3 times 20 gives me 60. Now again, because it is above that axis, that means that it is again moving to the right. For the very last section, part C, again we want to find the area between the line and this green highlighted axis that I drew. Now this one here, we're actually going to have to break this into 2 parts because it's neither a triangle nor a rectangle, but a combination of both. It is this section down here, which is a rectangle, and this section up here, which is a triangle. So we're going to find the area of that triangle and find the area of this rectangle and add them together. Let's start with the triangle. We have 1/2 the base times the height. The base in this case is from 7 to 10, which is 3. And the height, we're only talking about this triangle here. So from here, which is 2, up to here, which is 20. So that height is actually 18. Again, it's the area, or the height of just the triangle from 2 up to 20. So it's 18. We multiply this together, and we get 27. It's positive because it's above the axis. And then we get the area of this rectangle down here, which is length times width. The length is from 7 to 10, which is 3. And the width is from 0 to 2, which is 2. That area comes out to be positive because it's above the axis. It is positive 6 meters. So for section C, it is actually 27 plus 6, which gives us 33, positive 33 meters. And again, it is above that x-axis, so we are moving to the right. And the final thing it asks, it says to find the total displacement by adding all the sections together. So to get the total displacement, I'll write that up here. The total displacement I'm just going to take my numbers, 40, and that's positive, plus 60, that's positive again, plus 33, and that's also positive. If I add those all together, I get a positive 133 meters. What this means is that whatever object was moving has moved 133 meters to the right of where they started. What I'd like you to do is I'd like you to find the displacement of each section in this graph here, and then I want you to find the total displacement as well. I would say at this point, pause the video and try and find that. Again, we want to draw our horizontal axis here. You're going to find all your areas with relationship to that line. That's the 0. And then add them all together at the end. So pause the video, try that out, and then when you're ready, unpause and see how well you did. Okay, welcome back. So in this section here, we're finding the area of part A. So we're going to find between that 0 line and the line of the graph itself. So we're going to find this area. This is a triangle, so the area is 1/2 the base times the height. The base goes from 0 to 4, so that is 4. And the height is 0 to -4. So this is a negative height. This comes out to be -8 meters. Now you notice that this area is below the horizontal axis, so this is a negative area. This simply means that the object is moving to the left during this section. For part B, again, we're going to find the area between the line and the horizontal axis. This is again a triangle. So the area is 1/2 the base times the height. The base goes from 4 to 10. That means it is 6. And the height is from 0 to 6, or 6 again. If I take 1/2 of 6 times 6, I get an answer of positive 18. So the displacement is 18, which means being positive, they are moving right 18 meters during that section. For part C, we're going to find the area between the graph line and the 0 line. This is a rectangle. So my area is length times width. My length is from 10 to 12, which is 2. And my width is from 0 to 6, which is 6. This comes out to be a positive 12. Again, it is positive because it's above that horizontal axis. Because it's positive, that means that we are moving right. For the next section, part D, again we're finding the area between the line and that horizontal axis. This is going to make a triangle, and therefore the area is 1/2 base times height. The base is from 12 to 16. That's a distance of 4. The height is from 0 to 6. So that's a distance of 6. If I take 1/2 of 4 times 6, I get a positive 12. Again, it is above that horizontal axis. Therefore, it is a positive displacement, or it is moving right. For the last section, I'm going to again find the area between the line of the graph and the horizontal axis. And this is going to make a triangle again, which is 1/2 base times height. To get the base, it is from 16 to 20. That is a length of 4. To get the height, it is from 0 up until 10. That's a height of 10. If I multiply 1/2 4 times 10, I get a positive 20 meters. Again, it's a positive because it's above the horizontal axis. And it is positive, meaning it is moving to the right. Now we want to get the total displacement. So to get the total displacement, I'm going to take all my numbers and add them together. So I have a negative 8. I'm going to add to it 18. Add to that 12. Add to that another 12. And add to that a 20. Again, we must have the negative in there if there's a negative. If I add them all together, I get a positive 54 meters. That means that we have moved to the right (54 meters) from where we started. So wherever we started, we are simply 54 meters to the right of that spot. So again, to find the area is the same as finding the displacement. We have to draw where that horizontal axis is and find the area between the line and the horizontal axis.